सही जगह पे लगा है। मनप्रीत गुड इवनिंग बेटा. श्री भावनी गुड इवनिंग. Slightly better, slightly okay. Okay, shall we start the class? Beta, send the link and we will be starting talking about Dharni. Good evening beta. We'll be talking about periodic table. After this biology class will be there back to back. After that biology class I will be teaching double fertilization, and then today itself I'll talk about variation. Fine, so 2 classes will be there back to back today for class 10th, and then maths construction videos I'll be uploading. How to do the construction, that videos I'm going to upload today for maths class. Fine, so that your maths construction part will also get completed beta. I have to revise your syllabus, give sample paper tests, revisions, everything. For that only I have taken this decision. Sharan, good evening beta. Good evening Sharan. Please send the link in the group and tell everyone to join first. So last class we were talking about Mendeleev periodic table, Dobereinius law of trait and Newland's law of octaves. We have seen one very important thing there, and that is in all these conditions we have seen one small thing, that there was a trend that when we were seeing the Newland's law of octaves, or what you call Dobereinius law of trait, or we were seeing the Mendeleev periodic table, each periodic table has its own feature, has its way of presenting the elements somewhere exactly, but one thing was common there, and that was exactly the properties. Most of them tried to tell us one thing, that the chemical and the physical properties in the arrangement more or less resembles. So they tried to arrange the elements in such a way so that their physical and chemical properties will exactly get arranged. Okay, class 9th. No, class 10th beta. Class 9th when? Good evening. So now look here. So we have to understand one thing, that each and every element in the periodic table, they should have to be aligned in such a way. Abhirami, good evening beta. They have to be aligned in such a way so that they can show some similarities. Okay, now which type of similarities, physical properties or chemical properties, their presentation of element, everything will be exactly in presentation. It is written class 9th. Okay, don't see that presentation. Okay, I'm just moving it. It's class 10th only. That is what I got shocked, because beta health is not well na. Yes, health is not well, so I think I made again mistake in typing the class that I have started class 9th, and that is why I got shocked, Abakshya. It's class 9th, 10th beta. Yes, the periodic I just moved it. Thank you. Because of you, I at least laughed. Okay, Akshaya. Okay, Manpreet. Now look here, beta. So now we are going to understand about modern periodic table. See, defects were there. Another important point is defects were there. Okay, one simple question I am asking from all of you. Let's see how much information till now you have gathered. We have studied Dobereneus law of trade, Newland's law of octaves, and Mendeleev periodic table. These three periodic table now you are knowing. What was the basic idea behind forming a periodic table? What was the basic idea behind forming a periodic table? Basic idea behind forming a periodic table. Basic idea behind forming a periodic table. Let's see who can answer this question. What was the basic idea? Grouping the element. Absolutely. But grouping the element was one of the basic idea, but based on what, beta? Based on what? Grouping the element was one of the basic idea. Yes, very good. That is what we discussed one day, na? So I was exactly similar properties. Yes, Abhirami. So I am going to connect Akshaya's and Abhirami's both AA answered together, and I am going to say the statement. The basic idea was to group the element according to their similar properties. See how beautiful it is coming when I am adding both their statement. To arrange the element in order to remove the chaos. Very good, Manpreet. So that means another important point what Manpreet has given, based on their properties also. Yes. So our basic, now till now we have understood one thing, that okay, we wanted to classify the elements. Classification of element has to be done. Okay, so that there should not be any confusion related to the properties of the element, and because of that many times similar properties. Absolutely correct, Bhavani. So because of that many times they tried to arrange the elements. They tried to arrange the element, but the successive one, the one which got success, and the kept on successive word why I have used, because after Dobereneus, then Newland, then Mendeleev, and then modern periodic table, means we learned from our mistakes and then we gave a very stable periodic table. There most of the defaults defects what we have seen in Newland's or Dobereneus or Mendeleev periodic table has been overcome, and there the elements are exactly presented according to their similar properties were there, and physical chemical properties according to electronic configuration. They have exactly presented the elements in the periodic table, and which is quite stable in compared to that of the other periodic table. The elements were arranged according to their atomic number. That was one of a basic or important content related to modern periodic table. It stabilizes the periodic table. Okay, so modern periodic table is far more stabilized in compared to that of the other periodic table, or in compared to that of Mendeleev periodic table. I hope you might have understood this point. Until here I hope everybody might have understood. So Henry Moseley was the one who has exactly showed that atomic number of an element is more fundamental property than its atomic mass. Yes, it is. That's why I use the word stability there. Why atomic number is more fundamental property, more stability will be generated. Quickly tell me, beta, did you agree with the fact that this atomic number is exactly more in what you call fundamental? Atomic number is more fundamental, more stable. Can you agree with this fact? And if you are agreeing with this fact, can you give us can you give one simple example of it? Because more you will be able to type and write, the more you will learn the content. Okay. Yes, absolutely correct, Manpreet. But what is the reason behind this? Atomic number is the more fundamental property. Atomic number is the more fundamental property, because from this part I will tell you which section CBSE will ask question. They will definitely ask questions from there. One question either from case study section, or it will be exactly they'll give you a periodic table, they will give you some blanks and they'll tell you to fill it, or which is the most appropriate element filled should be filled in that place. They ask like that of question. Number of no two element has same atomic mass. no two element have same atomic mass or same atomic number. Sudarshan, good evening beta. No two element have same atomic. I really want one debate here today, and based on that only we will keep on understanding. So today my basic idea is my children will give the most important points. Good evening Kardiga. Atomic masses has different type of isotopes. That is a different thing we are going to understand, but more than that I really want my answer. More than that I want answer beta. More than that I really want that answer. Okay. Why it is fundamental, why after saying that, so then because atomic mass classification cannot be possible for higher elements, absolute, and in that Mendeleev periodic table, if you will see now, in Mendeleev periodic table between two atomic masses there was a gap between two atomic masses. See, look here, these are the very, very important basic points. We don't have to go to a very big theory or content, we just have to go to the basic point of it. When the two elements are having atomic mass, one atomic mass is 20, another atomic mass is 28.8, so between 20 and 28.8 there is a space for another element to get discovered. So whenever you will be exactly making a periodic table, you will never be so much what you call confident that in future there will be any other element which will exactly take atomic mass between 20 and 28. But when you are writing a periodic table based on atomic number, and the number starts from 1 to exactly 2, 3, 4, 5, 6, and you know that the numbers are discrete. Discrete means there will be no decimal system in between them. That means you are quite sure that the alignment of the elements, you are quite sure that the alignment of the elements have no gap in between them. So that's why we can consider them as fundamental. That's why we can consider them as fundamental. I hope you might have understood this concrete difference between atomic mass and atomic number. I want my children to be specifically writing the best important information. Okay ma'am, elements can be discovered in between. Yes, for atomic mass you can keep an element in between, but atomic number, they are discrete. Discrete means it can only be whole number. There will be no fraction or decimal values between them, and because of that there is no room or space in between two elements in the modern periodic table where you can invent or discover one more, where you can discover one more element. I hope you might have understood this point. This is a very important point I discussed, and the first line itself was very heavy, and for that only I wanted your what you called concept to be very clear from this point of view. So now onwards, whatever you have studied, wait 1 minute, screen is is the screen looking blur beta, or it's okay? So now did you understood this very massive thing in simple form? So atomic mass can never be fundamental, where you can take atomic numbers as fundamental part of it. I hope you might have understood this point in a very simple way. You can take this example as 20 and 28. In between there may be a space or room for getting one more element whose mass lies between 20 and 28. But when you are writing, Abhirami, it's okay auntie, understood na beta? Understood this point? Understood na? Did you understood this point? This is a very important point what I discussed right now beta. I really want my children to write very neatly and very accurately about this point. So now if we are going to go towards the law beta, you can say that the properties of elements are a periodic function of their atomic number. Okay, therefore its elements are arranged in order of their increasing atomic number. The element with similar properties are repeated after certain regular interval. This is what na SPDF cells are there. In there you might be seeing that the elements are repeated in particular order. Okay, so and in termed as periodicity and properties. So what is periodicity? if somebody will be asking you define the word periodicity in properties, then you are just going to mug the definition and you are going to vomit, or you are going to present your brain that what is exactly periodic law modified. Periodic law modified, yes, periodic law modified, and that is exactly called as periodicity. Come on, tell me fast, beta. So here I'm just repeating one more time, and then I'm wanting you to say in very simple what is periodicity in properties means. I'm repeating this content, and after that I'm going to explain in simple way, but I'm really wanting from you, what do you understood about this statement? The statement, I'm reading it out. The property of elements are a periodic function of their atomic number. Periodic function of atomic number, underline this part. Okay, and if elements are arranged in order of their increasing atomic number, the elements with similar properties are repeated after certain regular interval. This was given by Newland also, this was given by Dauberinier also, this was given by Mendeleev also. So what is new about it? What is new about it? All the three have said the same thing. Here modern periodic table also said the same thing. Means the one which is repeated after a fixed interval have same properties. Okay, so their repetitive pattern property, their repetition properties is termed as periodicity in properties, and the repeated pattern where they kept on repeating themselves is called as periodicity in properties. What does this mean in simple word? So Sudarshan tried to answer is periodic law modified, that is for atomic number, atomic mass. Correct, Sudarshan, but I really want to know this answer. I'm giving you time. What does periodicity in property means? Because here two concepts back to back running parallelly. Okay, one is the old concept and one is the new concept. One is the old concept. Akshaya, auntie, I am not able to understand the law periodic function, that one. So here you have to understand one thing, Akshaya, and that is so one very important, atomic mass to atomic number. Sudarshan, it is really connected. I really wish to elaborate this point. Yes, Sudarshan, why you deleted? Yeah, that's exactly the point. That's exactly the point. In shortcut, you tried to give the best answer. That was I was waiting for. So Manpreet, reoccurring of atomic properties after a fixed interval of time. Got it. Super, Manpreet. Bang on, beta. So the point what you have said is very well taken by me. I'm going to take this point 100%. Now look here, Akshaya. What Sudarshan and what Manpreet has said, it is exactly the basic point related to understand the modern periodic table. First important factor is modern periodic table does not depend upon atomic mass. It is depending on atomic number. But one thing is there, here two things are running parallelly. This is what I said. So here one thing is running parallelly is property. Now again we are switching towards our old concept. We are telling that after fixed interval, Michael, good afternoon, good evening, Michael. Today I am going to upload your video, Michael. Again I am going to upload the remaining videos, beta. Okay, evening I am going to make videos and I am going to upload. Maybe till 10:30 or 11 o'clock it will get uploaded. Huh? Like the valence electron, correct, Kartika. So you have to understand one thing, beta, here, that when two things are running parallelly here, first important thing is atomic properties, similarity in properties and arrangement of elements. Arrangement of elements and similarity in property. This was exactly done by Newland also, Dauberinier also, Mendeleev also, modern periodic table also. So modern periodic table also is considering the same point, arranging the elements according to its properties, so that whichever element will come in successive order in a particular what you call column, they resemble themselves. They resemble themselves. This is a very important point I said. If you want, you can listen to it one more time, or I am going to repeat it again, beta. And that is the most important point, beta. That two things are running parallelly here. Means the first is the properties and exactly arrangement of the element. And here also we are arranging the element. Akshay, understand. Here they are arranging the elements again according to their properties. Again according to their properties. But their most important main difference is previously we were taking atomic mass, now we are taking atomic number, and since we are taking atomic number, our periodic table is more stable. The modern periodic table which we are now referring is more stable in compared to that of the old periodic table which was based on mass, because between two masses of an element we were never sure that one new element may get discovered whose mass will be exactly between them two. Then how in the periodic table we can be so much what you call confident about that there will be no discovery of the new atomic new element in future, and that was, it has put a full stop in that. It has put a full stop in that. So I hope you might have understood, Akshaya. So that's why Sudarshan point and Manpreet point I have taken that very strongly, because Sudarshan talked about atomic mass to atomic number. Yes, we shifted from atomic mass to atomic number. That is exactly converting from general to fundamental. General to fundamental. And when Manpreet talked about that properties, so yes, we are again searching for the properties where the properties are exactly has to be similar. Then only na, see, in your family, if just take one simple example beta, in your family if 5 people are there, 5 people or 5 family members are there, in every time if all 5 family members are different, then family will never be stable. You have to understand one thing. In the same way, in the periodic table, if a particular column or a particular period, they have differences. Particular column first I am talking about, in group, a particular column, if all the elements have different properties now, properties means configuration I am talking about. I am not talking about what you call ionization potential or something. That properties I am not talking about. I am talking about configuration. If they will have different configuration, then that time they will not be stable. That time they will not be stable. Are you understanding this point? So come on, quickly tell me beta, are you understanding? Maybe I am having fever. I am unable to explain you nicely. So did you understood here? It was classifying element based on atomic number, then also repetition in similar properties takes place. Absolute, Sudarshan, you nailed the point now. Now you have we say na, in the coffin the last nail you have done in that point. So this is what. So now there is no room for new like content. Now we know that stability will be there in the periodic table. Arrangement of the element is very much specified and mistakes will be minimal there. Thank you, Sudarshan. So I think did you understood till here beta? So just understand that. Understanding, ma'am, super. So that is the only point here. Stability. You are presenting the elements in the most stable form in the modern periodic table, and more stability is generated when you are representing the elements in atomic number, not in atomic mass. Okay, so now, so what is periodicity in properties? Where the elements are arranged. Just understand what is periodicity in properties means beta. The elements are arranged according to their increasing atomic number. I repeat, the elements are arranged according to its increasing atomic number, and after a fixed interval each, means whenever repetition of element is coming, they will exactly have similar properties. So when they are repeated, they are having similar properties. When they are repeated, they are exactly, thank you, Sridhar. So when they are repeated, thank you, Sridhar. So when they are repeated, they are having what beta? They have similar properties. They are exactly having similar property. That's why it is called as periodicity in properties. That's why it is exactly called as periodicity in properties. What that word is called as? Periodicity in properties. Okay. So we have, I actually understood this point. Now if I want to elaborate this point, now you have to understand that in this S1 alkali metal, alkaline earth metal, when we are, okay, thank you, Latika. So now look here beta, in this you can see that first and second in S1 alkali metal or alkaline earth metal, like how you all are living in your family, there is a stability, there is an understanding. In the same way, the valency will be same, the valence electron will be same, and because of that valence electron, they will be exactly containing the properties similarly. Okay, so there will be no fight, no collision. Fine. So stability will be there. I hope you might have understood this point, so that we can go back to the next point beta. So that is called as periodicity in properties. So they will resemble each other like halogen family, noble family. So ionization potential. Now you will be having one very big confusion, because one simple part is there that when we discuss several things together now, confusions are coming. The most important confusion comes that, auntie, you know what, there is electron affinity, there is electronegativity, and you know what, auntie, on going from left to right now, everything is changing. On going from left to right now, auntie, everything is changing. Everything is changing. Electropositivity changes, auntie. Electronegativity changes on going from left to right. Also, auntie, on going from top to bottom also they are changing. Then how you are talking about stability? This is the first question children will ask. Because this is a general thing. If I am a student and my teacher is telling that ki, hey, there is a physical and chemical property similarity, then your next question will be, auntie, everything is changing, the properties are exactly changing, then how you can say? Then you have to understand one very important, left to right electronegativity increases. Absolutely. Thank you, Latika. God bless you, beta. So here everything is exactly changing. I'm agreeing with the fact, beta. But the most important point everybody skipped till now, because when I discuss this about property similarity, then I have put a halt or a gap in between them. Can you fill that part, beta? Can you fill that part? Can you fill that part? Can you fill that part, beta? And when I was discussing about similar properties, I told one thing, that gap can you fill about that similar properties, if you will be able to fill that region. Left to right change is there 100%. Manpreet, thank you so much, beta. When a student like you will be explaining the points, it's like very easy for a teacher to carry the content. I'm really waiting for my children to give more points related to it, because here certain things are there which you must discuss right now. Before going to a concrete evaluation, I really want some solid important information to feed in your brain, so that next time when we will call about physical and chemical properties now, that time you will not have confusion, because they're telling that in periodicity of properties the properties are similar. Then we are going to talk about different properties, and that time the properties will not be similar. That time you will have confusion that, auntie, in periodicity property now you talked everything, means the elements which will be arranging after fixed interval, they have similar properties, and now you are saying that on going from left to right, top to bottom, properties are different. Then either you stick to the previous point or you stick to now point what you are teaching. So I really want no confusion from periodicity property and the concept which I am going to teach in future. So only I am merging the content now itself and trying to explain the point. Okay, so it's your call right now, because how much you will scroll the part and how much you will try to modify the part, you will itself come out with a concrete answer. So I really want my children to come out with this concrete answer right now, so that in future you will not ask this question from me, I will ask this question from you. Okay, just tell me this point. Tell me, come on, quickly tell me this point, beta. Then you will, over? No one? No one gave the point? No one gave the point. I'm still searching. Answer is there in the screen itself. I have to move only. I moved. I moved. And I really want my children to now present the best answer. I moved. Now look here, beta. the most important point here is about, I told you in group, whenever the elements will be present, they show similar properties. Means after like hydrogen, then helium, then lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, then neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So all the elements will be filling each other one after the other. Now in group, whatever elements will be present, they resemble similar chemical properties. So we are not talking about physical property, we are talking here about chemical properties. So resemblance of the chemical properties in a particular group is very, very prominent. Okay, resemblance in, so I think Kartika, given element of same group have similar valence electrons, so they have similar property. Which property beta we are going to add here, Kartika? We are going to specifically use the word chemical properties. Okay, they have same electronic configuration. Means electronic configuration means the valence electron, the electron present in the outermost orbit, like first group is having one extra electron and they can donate one electron. So since group 1, all the alkali metals have a specific criteria of giving one electron, all the group 1 elements have one specific criteria to give one electron and gain the nearest noble gas configuration. Because of them, they are chemically similar. They are chemically similar. As per Mendeleev, now Mendeleev is an old story, Sudarshan. Mendeleev is an old story. Don't compile Mendeleev with your classification. Try to take him away. Try to take its periodic table away. Now you only focus towards modern periodic table and then see the answer. So if somebody will be telling you, will not talk about no physical property and change in shape, structure, its behavior. See, look here. One simple concept is what is electropositivity, what is electronegativity. The tendency to lose an electron, the tendency to gain an electron, the tendency to lose an electron comes under electropositivity. The tendency to gain an electron is exactly electronegativity. Okay, so these are exactly the properties. So these properties are based on the tendency to lose or gain. It has to do nothing with the chemical properties. The chemical properties in the group is same. The chemical property in a particular group is same, and that is what they are telling in the periodicity property. So that's why specifically I took my time to explain this. Last time I am repeating, the properties of element are a periodic function of their atomic number. Therefore, if elements are arranged in order of their increasing atomic number, the elements with similar properties are repeated after certain regular intervals. This repetition properties is termed as periodicity in properties. Causes of periodicity. What is the cause of periodicity? It is clearly written, the cause of periodicity is electronic configuration, and because of that similar electronic configuration, because of that they have similar chemical properties. I am not talking about electropositivity, negativity, shielding effect, screening effect, no effect. I am only talking about the alignment of the element in a group and why they are. That's why again and again I gave the example of a family. I kept on giving the example of a family with the help of a family, because in a family it is like when a family will be living in a stable form, so everyone will be correlating and conducting accordingly. So there also in a group, when all the elements are there, they have similar chemical property. So in a family, like DNA type, you just add biology in that, so everyone will be exactly connected to each other. If in a family member are there, mother, father, children are there, so DNA wise they all will be exactly similar. So here chemical property wise they all will be similar. This is the best example you think. This is the best example you think. In a group, how DNA wise family, father, mother, brother, children, grandfather, they are exactly similar DNA wise. In the same way, chemical properties in a group will be similar. I rest my case. Till here everybody understood? So what are the causes of periodicity? The cause of periodicity is same electronic, that means the similar outer electronic configuration. Similar outer electronic configuration will be there. Similar outer electronic configuration will be there. So they show similar chemical properties. They are showing what? They are showing similar chemical properties. Okay. So I am going to give a break. After that break, okay Sudarshan, so valency it forms so as to react with other element. Yes, that is what beta, similar outer electronic configuration. If you want to go for our outer electronic configuration beta, you will be seeing that more or less their outer electronic configuration will be same. Last valence electron 1 1 1 1. For alkali metal, last outer cell the electrons are 1 1 1 1. Alkali metal S1, you see lithium is there. Lithium is exactly atomic number 3. It is coming as 2 and 1. Then lithium, hydrogen, helium, lithium. After lithium, if you are going to take, I think some work is going on. So I have to take, I have to give a gap, and after that I'll start beta. Okay. Some construction work is going on beta. Yes beta, the valency across the group remains the same. Absolute Manpreet. So till now whatever point I have said, so alkali S2 means outermost electron will be 2 and they are capable of donating 2 electrons. And you know very ha li na ke rab susfar, ha li na ke rab susfar, be mag ka sar ba ra. So here beryllium, magnesium, that is calcium, everything will be having outermost 2 electrons, outermost 2 electrons to donate. So I think I know the periodic table like this. Ha li na ke rab susfar means ha li na ke rab susfar, be mak ka sar bara. So S1 S2 I remember like that. So whenever I need, I just use this shortcut method to write the periodic table. Okay. So like this I remember the full periodic table. Even you are also doing construction in class 9 ma'am. Yes beta, I am doing construction in class 9 right now. So I hope you might have understood this point beta. I hope you might have understood this point. Everybody understood? So electronic configuration wise in S1 block, that is alkali metal, every like outermost orbit 1 1 electron is there. Since outermost orbit 1 1 1 electron is there, so because of that only we can say that they have similar chemical properties. They have similar chemical properties. Ha li na ke rab susfar. So now here sodium is also, you know that sodium is 281, lithium is 21. Okay, so like that every time it will be coming outermost orbit, exactly electron will be 1. So same electronic configuration in the outermost part. So outermost orbit always 1 will be there. In outermost orbit always 1 will be there. In outermost orbit always 1 will be there. So only, that's why. I hope till here everybody understood. Understood till here everyone? Come on, quickly tell me beta. It's very difficult yaar. Chest is paining. Till here understood? Thank you Abhi. Sorry beta, I'm disappointing my children. So next time if somebody will be asking you, say clearly that this is the point. Chemical properties are same in a group. That's why it comes, it's an aid of periodicity in properties. It's a helpful aid in periodicity in properties and nothing else. Like that you give this point. Okay, now group 1 element. So you can see periodic table where you can see that group 1 to 18 is there. 1 2 3 4 5 6 7 8, total 18 is there. So there are certain names of this. Okay, so now first alkali, alkaline, these are transition metals. Now there are names of this. So shall we know the names of some of the groups of periodic table? So first group 1 is called as alkali metals. Group 2 is called as alkaline earth metal. D block group. The D block group is exactly called as transition metals. D block group is exactly called as what? They are called as transition elements. And group 15, they are also called as heavy metals. Group, that part will also be, you can also be reading the name that heavy metals. The transition elements are exactly heavy metals. Okay. Now after that, that pnictogens, that nitrogen family is there now, that is group 15. They are called as pnictogens. And now that is chalcogens are 16. chalcogens are 16, 17 is halogen, and 18 is noble gas. So element 1 to 2 and 13 to 8 are collectively called as representative elements. So pnictogens, chalcogens, shall we see pnictogens and chalcogens? Pnictogens and chalcogens, where is, I'm going to provide this PDF so that in one shot you can be able to go through everything. So this is exactly called as pnictogens, chalcogens, halogens and noble gas. Pnicto, chalco, okay, Nicto, so they are exactly, and you know what, this two group together, they are called as, these two collectively they are called as representative elements. So if somebody will be asking you group 13 to group 18 and group 1 and 2 together, they are called as representative elements. What they are called as? Representative elements. These are transition elements and heavy metals. You can also name them as heavy metals. This one is exactly called as pnictogens, chalcogens, chalco, oxygen part, and then halogens, and then noble gases. Halogens and noble gases. So now you are familiar with the name of the groups also. Are you familiar with the name of the groups also? Are you familiar with the name of the groups also, beta? So now, okay, familiar with name of the groups. So what and all group names are there? First is alkali, alkaline earth metal, alkali metals. Group 1, alkali metals, alkaline earth metal, transition, heavy metals. Transition elements are heavy metals, beta. Rahul, transition elements, good evening Rahul. Transition elements are exactly, beta, heavy metals. Next, these are exactly from here, pnictogens will be there, chalcogens will be there, then halogens, and then noble family. Okay. Now, next one, that is lanthanide and actinide. I am going to SPDF rule 1, lanthanide and actinide, that is anti-penultimate and penultimate cell shifting. One part, one day I will 100% be making a video and send you, so that in future nobody can say you that you don't know anything. It means one part itself is enough to understand the entire section of it. So now we are going to start with group. Okay, so what is exactly, how many groups are there in the modern periodic table? Then you will be saying that it is nothing to worry about, Sudarshan. Yes, beta. What is UUP? I have to check, beta, that element name. I have to check the name. Most of the UUP, I have to check. Name I don't know, beta. Name, most of the names, UUP, UU, they are exactly, name is given, urano, something is there. These are radioactive elements, beta. UUT, UUP, they are exactly radioactive elements. Some of the names are exactly 18. Yes. Okay, so beta, one more important thing is, so shall we go, these are exactly radioactive. After lanthanide, actinides, now whatever elements will be there, most of them will be radioactive elements, beta. Most of the elements will be radioactive elements. Name I am going to provide, but from here it is difficult to name it. I don't know the name of it right now. It is 115. Atomic number is 115, beta. Atomic number is 115. Okay, Sudarshan. So once I'll send you, you will be able to see. Shall we go for, I know the shortcuts, but right, UUP, like all the names I cannot be able, Now look here, beta. They will never be asking you the name. Electronic configuration properties means the one who will be discovering and doing, they will also forget the name. Okay, so now look here, beta. Now groups, in certain 18, how many total vertical columns are there? So total 18 vertical columns are there, and these vertical columns are called as groups. And we know that the valence electron in a specific group is fixed. Like S1, the valence electron will be 1. Okay, they have the, because the valence electron is 1, so valency is 1, so they are capable of donating 1 electron to gain the nearest noble gas element. Okay, to gain the nearest noble gas configuration, we can say better. So now all elements present in a group have same number of electrons in its outermost shell. Okay, so these groups are a number of, these groups will be starting from 1 to 18. These groups will be starting from where to where, beta? These groups will be starting from 1 to 18. Now periods we are going to know about. So periods will be exactly 7 horizontal periods will be there. 7 horizontal periods will be there, and they will be numbered from 1 to 10. Now they will be exactly, now one important thing is कि when we talk about group and when we talk about period, what is the difference between a group and a period? So a very massive difference is there. If you will be not able to recollect, I am going to recollect this part. Filling of electron is a certain different thing, but one thing always remember beta, in group na, in group first you see one very massive thing, if you should not skip. So only in group what you will be seeing that the valence electron will be same, the valence electron in the outermost orbit is same, but number of orbits are not same. Okay, number of orbits are not same, but in period if you will be seeing, the same orbit filling of electron will take place, same orbit filling of electron will be taking place, same orbit filling of electron will be taking place. So now did you understood the difference of it, the basic difference of it? Just generate a basic difference in group. Just see the electronic configuration means the outer orbit have same 1 electron. So down the group number of shells increases. Very good Kartika. Down the group number of cells are increasing beta, and number of cells each period is having one extra cell than the previous period. So total how many how many orbits will be there? Till period 7 orbits will be there. So each group will have 1 2 3 4 5 6 7 orbits. So first group will have one orbit, first group element will have one orbit, second group element will have two orbits, third group means first group first element, I am going to take like that. So that will first group means group number 1. We will start from here like this. Group number 1, first element, first period, second, third, fourth, like this. So period number 1, period number 2, period number 3, period number 4, period number 5. So with this what we have seen that in group, outermost group is tackling the valence electron, period is taking the orbit. So same period will have, so same period Manpreet, so down the group the number of shells increases, and across the period the cells remains the same, number of cells remains the same, and in that Manpreet you add one point, electrons get filled up in that particular cell. The electrons filling up in the particular cell is going on beta, electron filling up in the particular cell is going on. Okay, same cell electron will fill and trying to take you towards the noble configuration. I hope till here everybody understood group and period classification. I hope everybody understood. Isn't it not fascinating beta to understand these points? Understood beta? I hope you might have understood. Very good, Sudarshan. This is a very important point. I wanted my children to understand the basic part of it. Yes, beta. No, Kavya, maths class will not be there. After that, I am going to teach biology beta. Science, maths, statistics and construction is only there after that massive revision session. But in science beta, I have to teach you this periodic chapter and what you called 11th you are having exam. So I really want to finish everything in time. So only after this, I am going to start variations plus double fertilization. I don't want to skip a single topic also beta. Whatever is my health condition, that is a secondary thing. First is your examination. Yes, beta. So valence electron will be ongoing from left to right. See, valency is changing now. This one is having valence electron 1. It is having 2, 3, 4, 5, 6, 7. So outermost orbit here, valency is exactly 1. Valency is 2. Here valency is 3. Valency is 4. Then again it will be taking as 3, 2, 1, and this is noble gas. So here in the same period, in the same orbit, electrons are exactly added. In the same orbit, electrons are in the same orbit, the electrons are actually added. Okay, fine. I hope you might have understood. Yes, Kavya, class will be there tomorrow morning. From tomorrow I am going to start massive classes, beta. Massive classes. Okay, shall I start bio in 5 minutes? Beta? Okay. I hope till here whatever I discussed, I'm going to give Sudarshan, but right now my health is not good, so I'm not going to there. Hello beta, learner class 10th. Hello beta. 10 minutes gap. Okay, thank you so much beta. My children are thinking so much about me. Thank you beta.